Okay, somebody texted me and asked me for a few of these multiple choice questions. So, question number 4 is, which one of these groups doesn't make sense? Let's see, right? Which one is not possible? So basically the experiment has 4 female rats and 4 male rats, and they're going to do a randomized block design. So let's take a look at what that means. I'll get this out of the way. So they block them by gender, and so it might look like this. You've got the male rats over here and the female rats over there. Now what they do is they say there's 4 different treatments, and the treatments are called A, B, C, and D. A, B, C, and D. And then over here, the female rats, they get the same treatments, but we want to look at how the males react and the females react maybe a little bit differently. Anyway, here they are. So basically, you group up the male rats and then you randomly assign them to these 4 treatments, and you're going to group the female rats and randomly assign them to those 4 treatments. So basically what we're going to have is each treatment is going to have just one male rat, right? For treatment A, you have a male rat, whichever rat that is, rat 1, 2, 3, or 4, and one female rat. This is for treatment A. So that's the same thing for treatment B. There has to be just one male rat and one female rat for that treatment B group. So if we take a look at what they showed us, let's see. So look, these all have like one female, one male, female, male, female, male, female, male for each one of these different treatments, just like I lined it out over here. So the only one that doesn't make sense is a group that might have 2 males or 2 females, which is letter C. There it is. Letter C. Come on. Letter C. See? It says that group B would have 2 female rats. You can't have it. 1 male and 1 female. Okay, hope that helps. Let's go to the next question. Okay, here's question number 9. Mr. Clean is using dishwasher powder each day, and he uses basically the same amount every day. So which one of these statements is true? Well, let's look at number 1. So number 1 right here says that there's a high positive correlation between the number of days that have passed and then the box, since the box of dishwasher powder was open, and the amount of powder left in the box. So let's take a look at what that might look like. I'll just draw a quick graph here. If we do this, if this is the days, right, and this is the amount of powder, so day 1, 2, 3, and 4. Brand new box, right? Day 0, brand new box, and he uses a little bit this day, and then about the same amount the next day, and then the next day. Because it says how much is left in the box. Well, there's less left in the box each day that he uses it. Well, that is not a positive correlation. That would be a negative correlation. Okay, so this one does not make sense. Now, let's look at the other ones. So let's think about number 2 here. A scatter plot with days since purchase as the explanatory variable and the amount of dishwasher powder used as the response variable. So remember, let's see. Response variable is the y-axis, explanatory is the x-axis, and it says the amount used. Okay, so on the first day, actually when he buys the box of dishwasher detergent, he hasn't used any. But the first day, he uses a little bit, right? And then the second day, he uses more. And then the third day, they're talking about the total amount used. Each day, he uses a little bit more powder. So the total. So let's see, that would be a positive association. Let's see, and that's what they say. Where is it? a strong positive association. I would think that that would be the case, especially if he's using roughly the same amount every single day. Let's look at the third one. So 2's okay, huh? All right. Let's see, the third one. So this one, let's make a little graph here. And we'll say this is how much we have in the box. And what we're saying is, so brand new box, okay. After day one, the amount, let's see. So this isn't on days, it's the amount of powder left in the box and the amount of powder used. So the amount of powder left in the box, right, that goes down. Let's just say he uses 2 ounces, right? It goes down by 2 ounces, but he used 2 ounces. Oh ho, down to over 2. Well, if he uses like 2.2 ounces, down to, and then there's, see, he used 2.2 ounces, and the box would have 2.2 ounces less, right? They have to be about the same. The amount that he uses and the amount that the box goes down would be basically exactly the same. That would be a negative correlation, and think of it as a slope, down 1 over 1. It doesn't matter how much he uses. If he uses 4.3 ounces, that's how much less is in the box, and he used 4.3 ounces. They're exactly the same. So 3 is good. Okay. So what are we down with? Oh, choice D, right here. 2 and 3. Let's go to the next question. Okay, on this one, remember, when you're doing an experiment, you want to do things, assigning treatments as random as possible. Because, for instance, we're testing these 3, same car is going to be used for these 3 different weights in the car with these 3 different types of gasoline. Well, you could probably come up with a lot of different things that could happen if you started with Amoco gets to go first, right? And then we go from light to heavy. Well, that might affect how the gasoline or the car performs if we go from light to heavy. What if we go from heavy to light? There might be something in there. So we want to randomize as much as possible. Now, all these don't really talk about randomization. Let's see, this one does. But this one is really good. I like this one because there's 3 different weights and 3 different gasolines, right? So each gasoline is going to be used with these 3 different weights. So there's 9 different combinations that we can have between these 3 gasolines and these 3 different weights. So we mix them up as much as we possibly can. That's letter D. That's a good one right there. 9 combinations of weight and gasoline, and then just put them in a random order. And make sure you get, each one is done once. Well, here, this one doesn't work because randomly select an amount of weight and the random gasoline and run the car on a test track. Repeat this process a total of 30 times. If you do that 30 times, randomly, there's a possibility that you run the same gas with the same weight all 30 times. So we want to make sure that every gas and every weight gets used. So letter D is the best way to do this in the most random way. Okay, totally random. Now let's do the next and last question. Okay, these types of questions, I always struggle with these things no matter what. But here's what I do. I'm going to take this. What's kind of nice is that they put this in order from least to greatest. So it's kind of organized. What I'm going to do is I'm going to think about what a bar graph would look like. So for less than 10 minutes, I'm going to make a small bar like that. That's 5. I'm just going to estimate what this might look like. 24, let's just say it goes up here like this. I know this isn't very accurate, but I just want to see what I get. This is a really tall bar, 45. Way up there. This one is 38, like this. I kind of have an assumption here. Then we have 19. That's a little bit shorter than the 24. And then we have 7 and 2. So my assumption was that this data is skewed, which it looks like it is. It looks like it's skewed to the right. Just a little bit. like this, longer tail on the right side. It's not completely symmetric, which means that the mean is going to be bigger than the median. Now, does that help us? And yes, it does, because look at letter A. It says that the mean is going to be smaller than the median, so I can say that's not going to be a good one right there. Now, the median is that middle number. So these are patients that are waiting for these different times, right? I'm going to figure out what is the, and it, like I said, it's nice. They kind of arrange them from lowest to highest here. So I'm going to figure out what the middle number is. I added all these numbers together, and I got 140. So the middle number is that 70th number, like that. So I'm going to try to figure out where that is. So I'm just going to add these numbers up. So 5 plus 29 gives me, whoops, my bad, I'm jumping ahead here. 5 plus 24 is 29, plus 45 gives me, ooh, well, that's 74. So we're already at 74 patients. So it's a little bit, it's got to be in this group, right? Right here. So the 74th person is in this group where there's 45 patients right there that had to wait. So it looks like it's going to be in that range. So I said, and you can see I marked it already because I did this problem. Let's see, the median is about 28 minutes. Well, that makes sense, right? Because somewhere between 20 and 30 minutes, that's the median. And the mean is a little bit bigger, and that is the correct answer. There you go. Hope that helps. Okay, text me again if you want some other questions done. I love it. All right, see ya, bye.